Okay, so now we're going to be looking at this inferences, but now we'll be dealing with two samples. The first thing we need to look at is are these two samples dependent or independent of each other? If they're dependent, then the members of one sample are used to determine the members of the other. This is often in a before and after case, where the two samples are the same person before cholesterol medicine and then cholesterol readings done after cholesterol medicine. If they're not the same person, then there is some kind of definite relationship between person 1 in sample 1 and person 1 in sample 2. Two samples are independent if the sample values are not related at all. Now, the first one we're going to look at are inferences about two proportions. And we'll have two proportions from two samples that are independent of each other. For each sample, we're going to look at the number of successes and the number of failures, and they both need to be more than 5. This is very similar to what we saw with one sample. With one sample proportion, we were comparing a sample value to a claimed value. Now we're going to be comparing two sample proportions to see if they come from the same population. We will again have a null and an alternative hypothesis. The null hypothesis will include equality, that the two samples are equivalent, come from the same population, or one sample is different than the other, one sample is less than the other, or one sample proportion is greater than the other. We will use Minitab to find the p-value and then compare the p-value to a significance level, just like we did with the one sample proportion test. We will use the pooled estimate for hypothesis test, but we do not use the pooled estimate for confidence intervals. You will see on the option page when you go to Minitab and you go to proportion, when you hit options, you're going to have the option of checking a box saying use the pooled estimate. You check that box if you're doing hypothesis tests, but do not check the box if you're doing a confidence interval. Then you'll make the decisions based on comparing alpha to the p-value just like before. If the p-value found is less than or equal to the significance level alpha, then we reject the null hypothesis and state that there is a difference between the two proportions. When we use Minitab, we're going to go to stat, basic stat, and then to sample p. You'll enter the appropriate data. You'll select pooled estimate if you're doing a hypothesis test. You do not select pooled if you're doing a confidence interval options, and you select the appropriate alternative hypothesis. And confidence intervals estimates for P1 minus P2. If P1 minus P2 has a confidence interval that does not contain 0, then we say they are statistically significantly different. But if the confidence interval does contain 0, then we say there is not a difference between them. All right? So remember, we do not use the pooled estimate when we're doing confidence intervals. So here's an example. This example is in your Minitab lab book, and we're looking at the results from surgery-based versus a wrist splinting. We took a sample of 73 people who had the surgery, and 67 of them had a successful surgery. We had 83 that did wrist splinting, and 60 of them were successful. We want to test the hypothesis that the results are better with surgery than with wrist splinting. Remember, with hypothesis tests, you're going to use the pooled estimate, and in this case, our alternative is greater than. Our null hypothesis is P1 equals P2. We call P1 the surgery and P2 being the splint. Then we're saying P1, the alternative is P1 is greater than P2. All right, when you put this information into Minitab, you're going to get a test statistic of Z equals 3.12 and a p-value of 0.001. Now our conclusion, P is certainly less than alpha, thus we reject the null hypothesis. There is enough evidence at the 5% significance level to say results for the surgical group were better than for the splint group. If we want to do a confidence interval, let's construct a 90% confidence interval with this same set of data. Now remember, since we're now doing a confidence interval, we need to go back and uncheck the box that says use pooled estimate for P. We want to change the alternative to not equal to. That's the only way we'll get both the lower limit and the upper limit. Then you should get that the 90% confidence interval is there. Since 0 is not in this interval, we again come up with the same conclusion. We reject the null hypothesis. There is enough evidence. Now with the confidence interval, all we know is there is enough evidence to say there is a difference between the two proportions. Now we're going to move on to inferences about two means. The first one we're going to look at are independent samples. In this case, the two samples must be chosen independently of each other. Both samples need to be simple random samples. And either both samples are bigger than 30 or both samples come from a population that is known to be normally distributed. There are three types of problems. First, the standard deviations are known. The population standard deviations from these two populations are known. In that case, we use the normal distribution. Or it can be assumed that the two standard deviations are equal to each other. Then we use the t-distribution with a pooled standard error. Otherwise, we use the t-distribution for an approximation. Now, there will be a place on Minitab that says assume equal variances. Unless you know that the variances or standard deviations, the population variances or standard deviations are equal to each other, then do not check the box. Now, number one is very rare and is not even dealt with by Minitab, but it is in your book and you can read about it. So to use Minitab for a two independent sample t-test, you go to stat, basic stat, two sample t. You enter in the appropriate data. If it is known that the population variances are equal, then check the box. If it is not known, and leave it unchecked. It is better to not check that box unless you are sure that the population variances are equal to each other. Go to options and select the appropriate alternative hypothesis. So here's an example from your lab book. We're going to enter the ages of unsuccessful applicants in C1. You'll find these examples in your Minitab lab book. Enter the ages of successful applicants in C2. Now we want to test the claim that unsuccessful applicants have a mean age greater than the mean age of successful applicants. When you put this information in, you're going to get a test statistic equal to 1.63 and a p-value of 0.055. Since p is greater than our alpha, which is 0.05, we fail to reject the null hypothesis. There is not enough evidence at the 5% significance level to say that the mean age is greater for the unsuccessful applicants. Now, suppose we want to look at inferences from matched pairs. In this case, sample data comes from matched pairs. The samples are simple random sample, and either both samples are bigger than 30, or they come from populations that are known to be normally distributed. Note the hypotheses here are based on mu sub d, the mean of the differences, but Minitab will do these differences for you. So in using Minitab, you enter the data into two different columns. Then go to stat, basic stat, paired t, go to options and select the appropriate alternative hypothesis, and Minitab will give you a test statistic and a p-value. Again, let's look at an example from your Minitab lab book. In this case, we're going to be comparing the actual low temperatures versus the forecasted low temperatures. We're going to enter in the actual low temperatures in one column and the forecasted low temperatures into the second column. And we're going to test the claim that there is a difference between the two. So in this case, our alternative hypothesis is not equal to. We get a test statistic of negative 0.71 with a p-value of 0.519. P is certainly greater than alpha, which means we fail to reject the null hypothesis. There's not enough evidence to suggest that there's a difference between the actual and the forecasted temperatures. Now we're going to look at the last type of two-sample test, and we're going to be comparing variation, either comparing standard deviations or variances. The requirements in this case are the two populations are independent of each other and both need to be normally distributed. This uses an F distribution, which is similar to our chi-square distribution. And it is also not symmetric and skewed right, just like the chi-square. All values are greater than or equal to 0. The exact shape of the distribution depends on 2 different degrees of freedom, and large values of F are evidence against the null hypothesis. Again, if you read the lecture notes that are on the portal under documents, you can see all these formulas, but the formulas are not necessary to understand how to interpret the Minitab results. So using Minitab, you go to Stat, Basic Stat 2 Variance. You enter the appropriate data using either the data that's entered into into 2 columns, or you can be given the sample statistic, either the sample variance or the sample standard deviation, and the summarized statistics. Enter that in if that's what you're given. Then go to Options and select the appropriate alternative hypothesis. Again, you'll get a test statistic and a p-value, which you can compare to a significance level. Now, that's the end of this lecture. If you want to read the formulas, just look at the lecture notes, but they're not necessary to do the interpretations with Minitab.